Welcome to Mr. Benjamin's Math World. Today we are going to be working in solving system of equations. It's a system of equations because we are going to be working with two equations at the same time. Let's take a look at this. This system of equations is called equivalent equations. Why is it equivalent equations? Because if you notice, here it says x plus y equals 4, equation number 1, and equation number 2 says 2x plus 2y equals to 8. You may get this equation out of this one just by multiplying each term times 2. If you multiply 2 times x, you get 2x. If you multiply 2 times y, you get 2y. And if you multiply 2 times 4, you get 8. The same as if you divide 2 divided by 2 is 1x. If you divide 2y divided by 2 is y. And if you divide 8 divided by 2 is 4. So this is why it is called equivalent equations. A system of equivalent equations has an infinite common number of solutions. What happens when it's not a system of equivalent equations? They are called independent equations. So as you can see, there's no way you can get the same one out of the other one. It's not possible. So this is called independent equations. And a system of independent equations has only one common solution. It means that the result that I get out of this equation must also satisfy the second equation. How can we do that? By using different methods of elimination. The first method we are going to be using is called elimination by equalization. What does that mean? Well, this term means that I need to get clear one of these two equations and do the same in the second equation. It means that equation number 1, this one, I'll clear the x. In equation number 2, I will also clear the same letter x. Let's see the steps. I'm taking the first equation, I'll copy it over. 7x plus 4y equals 13. So let me clear the x. 7x equals 13 plus 4y goes to the other side, the opposite of operation, as we know. Plus 4y goes to the right, minus 4y. And then 7x equals 13 minus 4y. In order to get rid of the 7, I need to move the 7 from the left to the right. The operation involved on this side is a multiplication. So if I change the 7 from the left to the right, will be the opposite of the multiplication, which is division. So x will be 13 minus 4y divided by 7. I already got x in the first equation. So I need to get the same x, but in the second equation. I'll copy the second equation right here. 5x minus 2y equals to 19. Therefore, 5x equals to 19. This is subtracting, as you can see. It's subtracting on the left, so it goes the opposite of subtraction, which is addition. So it will be 19 plus 2y. And then I need to get rid of the 5 in order to get the x by itself. So this will be x equals 19 plus 2y, and the 5, which is multiplying, because we know that 5x means 5 times x. It's a multiplication. The opposite of the multiplication is division. So it goes from left to right, dividing. And then we have that x equals 19 plus 2y divided by 2. What have we done? It's a 5 divided by 5. It means that we have gotten the same x on the first equation and the x on the second equation. And the name of it is equalization. It means that I need to get these two equations equal, and I'll do that. Since x equals 13 minus 4y over 7 and x equals 19 plus 2y over 5, these two are the same. Therefore, 13 minus 4y over 7 equals 19 plus 2y over 5. And then now I need to solve this equation. It's an equation because it has an equal sign. And if we remember what we have worked in before, we may use proportion in order to solve this equation. It means that I may multiply this 2, and I also multiply this 2. Kind of messy, but it will come out. So this will be 5 times 13 minus 4y equals, I just multiply these two, equals 7 times 19 plus 2y. I have an equation one more time. It's an equal sign. Again, I just cross multiply. 13 minus 4y times 5, but multiplication is commutative. It means that you may multiply 13 minus 4y times 5 or 5 times 13 minus 4y. Same as 7 times 19 plus 2y. Here it is.